All right, in lesson 2 in module 2, we are talking about translations. So we did, in our last lesson, we talked about the 4 basic transformations we were going to be dealing with. We have our 3 isometries or basic rigid motions, translations, which we're talking about today, reflections, rotations. And then we have our 4th transformation, we're talking about a dilation. Dilation is the only one that changes the size. Okay, so our focus today is on translations, and we're going to do it thinking in the coordinate plane, right? Our x and y axis. So it says a translation moves every point of a figure the same what and the same what. Okay, so in our power standards, remember I've told you to think of it as you're moving the points, the vertices. Not that you just have to necessarily move the entire figure, but if you move the vertices, the points, that kind of takes care of itself. So when we move every point of a figure, we're going to do it in the same direction and the same distance. If I'm moving one of them 5 units, I'm not going to move the other one 4. Okay, I'm going to move them the same distance in the same direction. So what that means is it can move a figure left and right. And we're going to talk about, squeeze it in there, what that means, what direction we're going. We're talking about left or right, meaning positive, negative. And it also means we can go up and down. Now, sometimes we won't. Sometimes we don't have to go up. We may just move left. Sometimes we're going to go down and to the right. So just different types of translations, but they're moving in the same direction, the same distance. We think of them as a slide. So translations are also thought of as slides. You're sliding things around. Okay? All right, so let's take this here and let's put it into practice. Okay? So if I want to translate this figure right here, okay, let's talk about this figure. It's a triangle. We have our vertices A, B, and C. It says translate the figure 5 units left and 2 units down, and then record the coordinates of the pre-image and image in the table. Okay, so remember, let's start with this. Our pre-image is the one we have. The image is going to have the prime symbol by it, the apostrophe. So let's start actually with the pre-image. I know it says to do that after, but let's say we're going to start with A here. Okay, what are the vertices of A? So remember, we have the x coordinate first, then the y. So this happens at the x value of 2, the y value of 4. Then we have B right here. And these are our pre-images. Our original images are pre-images, and that occurs at the x value of 6 and the y value of 7. And then we have C. And that happens at 7, 3. Okay, so now we want to move it 5 units left, 2 units down. Think each point, okay? So if I want to take this point A here and move it 5 units left, that's 1, 2, 3, 4, 5, and then 2 units down, 1, 2. Okay, so that's where our new point's going to be. Now remember how we differentiate, but still show the relationship between A, the pre-image, and the new image, is we call this A prime. Okay, so down here, A prime is going to be at -3, 2. All right, so now we do the same thing with B. We're going to go to the left 5, 1, 2, 3, 4, 5, and we're going to go down 2, 1, 2. 1, 2, 3, 4, 5. Sorry, my marks are off just a little bit, okay? But this will be right here, okay? So this is B prime, okay? That's how we know it's kind of the image of B. And B prime is going to be at 1, 5. All right. And then we have C. 1, 2, 3, 4, 5, 1, 2. And this will be C prime, and that occurs at 2, 1. So if you connect it, remember, it should look like the exact same shape. Okay, not that you have to, but if I took my little marks off, you would see that this looks exactly the same. Okay, we moved each point in the same direction and the same distance. Okay. Now it says, look for any patterns and describe what happened to x and y values in each ordered pair. Okay? Well, our patterns, well, the x value went from 2 to -3, right? 2 right here, -3, which would mean we could say moving left 5 units decreased all, because it happened to all of them, of the x values by 5. Okay? So we moved A5, we moved B5 to the left, we moved C5 to the left. And notice we went 2 minus 5 is -3, 6 minus 5 is 1, 7 minus 5 is 2. All right? Now what else did we do? What did we do with the y values? We came down 2 each time, right? So we can say moving down, and spelling it right, as always, 2 units, maybe typing isn't better, right? Decreased all of the y values by 2. All right. So these two things happened, okay? When we moved our points, not only did we move them left, but we decreased our values by 5. And we decreased, okay, our y values by 2. And this is how we could explain it algebraically. We will go over that in just a second. All right, let's do this next one really quick. Okay, this time we want to go 4 units right and 3 units up. So if I quickly record my pre-image here, D is going to be at -7, -4. E is going to be at -4, 1. And F, the values are at -3, -5. So if I'm moving this one 4 units to the right, 1, 2, 3, 4, and 3 units up, 1, 2, 3. Ooh, and I should have started D. I'm sorry. That's okay. It really doesn't matter. E prime is going to be at the point 0, 4. Okay. Now D, if I move that 4 to the right, I'm just going to count it. 1, 2, 3, 4, and 3 units up. 1, 2, 3. D prime right there occurs at -3, -1. And then F, if I count that 4 to the right again, 1, 2, 3, 4, and 3 up, 1, 2, 3. F prime is going to occur at 1, -2. So what patterns do we see? Well, I probably should draw my triangle, right? And again, guys, we have to anticipate this is going to look the exact same thing, just slid, because that's all we did. So what happens? Well, when we moved it D4 to the right, notice our x value went from -7 to -3 and moved 4 to the right. So we're going to say again, moving 4 units, sorry, moving right 4 units, increased all of the x values by 4. Okay. And then our second one, notice our y values. I went from -4 to -3, from 1 to 4. I'm increasing them by 3. So I'm going to say, or try to say at least, moving right, nope, moving up 3 units increased all of the y values by 3. Not a coincidence, right? That's what we kind of expect. So the last thing I want to cover real quick is just how do we explain this algebraically, okay? So what are we going to do to this point here to get this point? And this is called coordinate notation. Okay, so coordinate notation tells us what we're doing to each of the points, but algebraically instead of in words. So what are we doing to the x value? Well, we're decreasing, in this case, the x values by 5. So I'm going to take whatever my x value is and minus 5. 2 minus 5 is negative 3. 6 minus 5 is 1. What am I doing to the y values? Well, I'm decreasing them by 2. So I'm going to take whatever my y value is and decrease it by 2. 3 minus 2 is 1. 7 minus 2 is 5. 4 minus 2 is 2. This right here is our coordinate notation, and it tells us what we can do to the points without having to graph them. So just to finish up here, coordinate notation representing our words here algebraically. Our x values are left to right movement. So if I'm moving right 4 units, I'm taking whatever my x value is and adding 4. Negative 7 plus 4 is negative 3. Negative 4 plus 4 is 0, right? And then our y values, if we're moving up 3 units, that means whatever my y value is, I'm increasing it, or I'm adding on 3. Negative 5 plus 3 is negative 2. 1 plus 3 is 4. Okay? So this coordinate notation tells us how we can perform the translation without writing it out in a bunch of words.